Welcome back to Calculus 1, and this week we'll be talking about can you figure out if a function is increasing or decreasing without using any type of calculator. So to answer this, we must find f prime of x first, or the first derivative of f. The next step is to set f prime equal to 0. These are your critical points, and you have to make sure they fully pass through the x-axis in order for them to be of any sort of value in this case. And then we will learn how to create a sign chart. Okay. The fundamental, and before I move on, we'll define what a sign chart is later. So if f prime of x at some sort of point is greater than 0, f is increasing at that point. And I want to stress that, remember, there is no prime on the f is increasing part. And then vice versa for f prime is less than 0, in which f is decreasing. Okay, practice. Where each function, so find where each function is increasing or decreasing. Okay, so first in our sort of algorithm, we'll call it, we were taught to take the first derivative, well, firstly. So the derivative of this will be 3x squared minus 6x, okay? And then we want to set it equal to 0, right? So 3x squared minus 6x is equal to 0. And we'll take 3x out, it's a factor, so it'll be x minus 2. And then we know our critical points are x equals 0 and 2. Then we'll set up a sign chart. So sign chart is like this. So we'll put bars where our straight lines where our critical points are. So that's just going to be 0. The other one's going to be a 2. And if I'm giving no endpoints, I'll just put positive infinity here and negative infinity here. You may be given endpoints, but here we're not. Okay? Then we will plug in random values in this interval, and this interval to see if it's positive, negative, and f prime. So first, let's say 1 is perfectly in between 0 and 2, so we can do f prime of 1 and see what that gives. So we know that 1 is perfectly in between 0 and 2, so you can find f prime of 1. So, well, 3 times 1 squared is 3, minus 6 times 1 is 6, this is negative 3. Is negative 3 less than or greater than 0? It's less than, so it's going to be decreasing on this interval. Okay, so, well, then for the next interval, this one, so let's draw an arrow to clarify it. Then the next interval, so 2 to infinity, well, anything greater than 2 should work here, right? So let's just do 3. So 3 times 3 squared is going to be 27. And then 6 times 3 is 18. I know this is 9, but I know it's going to be greater than 0. So it's going to be increasing because it's positive. And then vice versa with, well, not vice versa, but same case with 0 to negative infinity, or negative infinity to 0, and which we will plug in negative 1. And then negative 1 squared is times 3 is going to be 3, plus 6 is, we know it's going to be 9, but it's greater than 0. So it's going to be increasing. So I know that from negative infinity to 0, union 2 to infinity, this is going to be our increasing intervals because the derivative is positive at those points in that interval. And then from 0 to 2, it will be decreasing. And that is how you make a sign chart. So moving on to number 3, we're given j of x is equal to x to the 4th minus 4x squared. So I'm going to take, like our algorithm tells us, we're going to take the first derivative first. That's equal to 4x cubed minus 8x. And then we will just take the, we'll just set it equal to 0 to find the critical points. We'll take out 4x, and this will be x squared minus 2. Did that right? Yes, I did. And then it's going to be equal to 0. So then we're given x is equal to 0, and then plus or minus the square root of 2. Okay? So then we're to set up a sign chart here. Be a little bigger because we have 3 critical points now. So plug in, put 0 in the center. Square root of 2 on the right, then negative square root of 2 on the left. Then just we're not given any endpoints, so I'll put negative infinity and positive infinity in the ends. Okay. Same procedure like we did the last one. I want to pick a number between 0 and the square root of 2. 1 works because square root of 2 is approximately 1.414. So let's try to find f prime of 1. So f prime of 1, just put it there, put negative f prime of 1. That's going to be equal to 4 times 1 cubed, which is 4, minus 8 is going to be negative 4. And I know it's negative, so since negative 4 is negative, it's going to be decreasing. Okay, what about for the negative root 2 to 0? Well, the negative root 2, we already clarified that root 2 is 1.414. And then just the negative of that is negative 1.414, and that's in between negative 1. Well, that negative 1 is in between those two, so we'll do f prime of negative 1. And that won't change. That's going to change a bit. So we have negative 1 cubed is negative 4. Well, not negative 4, but negative 1 cubed is negative 1. And then 4 times negative 1 is negative 4. And then negative 8 times negative 1 is plus 8. And that's going to be positive or positive 4. So we know it's going to be increasing. And then just for the outer intervals, we could try 2 on this side. F prime of 2 because it's in between. And then we get so that's going to be 2 cubed, it's going to be 8, then 8 times 4 is going to be 32, and 32 minus 16 is going to be positive, or just positive 16, so I know it's going to be increasing. Then we could just do the opposite here, well, opposite, but take the negative f prime of negative 2, and then we have negative 8 times 4 is going to be negative 32 plus 16, and that's negative, so it's going to be decreasing. So just to state our conclusions or our answers, we know that's going to be decreasing from negative infinity to negative root 2 to and 0 to root 2. Then it's increasing from negative root 2 to 0, and then root 2 to infinity. All right. Next one. So like we said, we're going to follow the same algorithm. So g prime of x is equal to 6x squared plus 6x minus 12. And we're set it equal to 0. Then we'll just factor it. Then we're given x equals negative 2 and 1. Then we'll set up our sign chart. That's fine because we only have 2 points, so I'm not very, 2 critical points. I'm not very picky where how I make it. So it'll be positive infinity, then negative infinity, and then we'll just plug in test points for each interval. So in between negative 2 and 1, 0 sits in there, so g prime of 0 is going to be negative 12. So negative 12 is indeed negative, so it's going to be decreasing here. All right, what about here? Well, we could try g prime of 2. So that's going to be, I don't even have to plug it in. I already know it's going to be positive, and that's the only point, because I know that 6 times 2 is 12, minus 12 minus 12 is 0, so it gets rid of the negative factor. So it's going to be 24. But I didn't have to plug it in. I already knew it was going to be positive just by looking at the graph or visualizing it in your head. Okay, and then for the last interval, negative 3 will suffice here. And then we could do 6 times 9 is going to be 54, minus 18, minus 12. Like again, we don't have to evaluate it. We already know it's going to be positive, so it's going to be increasing. So just to state it, it's it's going to be increasing. For negative infinity, negative 2, union, so union, 1 to infinity, and then it'll be decreasing, negative 2 to 1. Okay. So those were how we did it with polynomials. Now we have a non-polynomial function. It's a little more tricky, but it's doable. All right, so we're going to follow the same algorithm. So we take the first derivative, so it'll be f prime of x is equal to, so here we're going to use the product rule, not the power rule. So it'll be 2x e to the negative x, then minus x squared e to the negative x. And then we will set it equal to 0. So this would be 2x e to the negative x minus x squared e to the negative x is equal to 0. And then here I'm just going to take out x e to the negative x. And then we have 2 minus x is equal to 0. And then we are given x is equal x e to the negative x, not equal, is equal to 0. And then x is equal to 2. So let's look at this one. Is there any value of x that makes this equal to 0? And yes, indeed, and it's x is equal to 0. Okay. So let's make our sign chart. So put 0 here, 2 here, and then our infinities on both sides. Then it's now a matter of just plugging in. So 1 is between 0 and 2. Second due, what we call it, f. So it's going to be f prime of 1. So f prime of 1 is going to be, let's factor it here. So rather than just using this function, we're better off using that function because it's a simplified form. So it's going to be positive because 1 times e to the negative 1. So it's going to be 1 over e, then times 2 minus 1, which is just 1 over e. 1 over e is positive, so it's going to be increasing here. And then from 2 to infinity, we can pick any number, but 3 sounds the best here. And then since this quantity is always going to be positive for when x is positive, but this isn't, so we can check that quantity. So 2 minus 3 is negative, so it's going to be decreasing. And then for here, we could just check negative 1, because that will suffice. And then we will have negative 1, then times e times 3. It's going to be decreasing here. So just to sum it up, I'm going to say decreasing when negative infinity to 0 and 2 to infinity. And then it's increasing for 0 to 2. All right, today we learned how to find when a function is increasing or decreasing without the use of the calculator. I hope you learned something new, and I'll see you next week.